Okay, take two. Demo is we can make it longer or shorter. Well, anyway, I think you folks have already seen my slides moving, and do you see it? You know what? I will triple check again if you forgive me my switching back and forth, but you are still getting. No? All good? Somebody saying not good. Slides. You see you, Peter. Okay. Let's hope it works. Okay. So we're going to talk about optimization and troubleshooting, to do a quick intro in PMM and to do a demo. And I will move through those relatively quickly. So we'll talk about performance optimization and troubleshooting in this case. The difference, as I can see that, is where performance optimization is focused on performance only, and that is something you want to do proactively so you can catch performance problems before they appear. Hopefully you catch most of them in development, though I know you'll catch some of them in production as well. Where it comes to troubleshooting, though, you inevitably have to do that, again, both in development and production, but reactive in nature. If you look at from the outcome standpoint, as a developer, you probably want to have this database to work. In my experience, many application developers do not really understand the database internals very well, and that can be an interesting problem. As a manager, the database to run, right, and not cost a lot of money to do so. And hopefully you want to keep your both a developer friend and the manager happy without every day. Now, database is from a very high level. It is you connect to the database from application, you start to issue queries, and if those queries have great performance, provide correct results, and not impact other applications, and not use too many resources, then you are probably good. And here, and why the queries are important, what the queries in the end are application responsibility. The kind of queries and the volume of queries really depends on application itself. And if application generates high volume of horrendous queries, there is never a database which handle it all. The thing about is resources which are available for a database to run. And in this case, if you did not provision enough resources, then even well-tuned database and the well-written applications will perform poorly. What do I mean? Then, well, these are your resources: the CPU, memory, disk, and which is what tends to impact the database performance the most. Now, when you're thinking about utilizations, of course, a lot of that will come from the which are done by the application you're working with. But you also have to consider there may be some other resource usage caused by the other sources, such as the other queries, database background activities, maybe other processes on the same neighbors and the same node. And depending on your virtualization environment, you may have noisy neighbors by other processes, containers, or VMs having the impact of the same physical resources. Now, as a practical approach to optimize performance, you query side or from the resource utilization standpoint. And Percona monitoring management really enables both of those viewpoints. monitor and manage.
Is our purpose-built monitor and managability platform, which is
focused on the databases. It is 100% free and also we are adding more functionality in this platform to help you to not only to monitor but to manage databases and even to provide you database as a service experience. You can check out another talk we have introducing the technical preview of database as a service functionality in PMM. PMM is designed so you run environment which you can do in the clouds or on-prem. It supports MySQL, MongoDB, Postgres, the top primary databases Percona supports, as well as MariaDB, as well as the cloud-based deployments of such databases, such as Amazon RDS, Google Cloud SQL, and so on and so forth. Right. So what we hope is what PMM will help you to get your development and ops teams on the same page to build the better applications faster and overall run open source databases better, more efficiency. 2 is our major right, and it comes with a lot of new goodness, such as support for large environments and but well, that is something you will see in a second when I will demo that. Here are for
sources, which if you want to check out PMM beyond what we'll see
now. So with that, let me try if a second time is a charm, and if it worked. Yes,
looks like
people see me and hear properly. Now, let's see how that will play out with a demo. Demo. Okay. Hopefully you can still see everything. So this is how the PMM landing page would look like, and it shows us the overview of your servers. In a lot of cases, if you want to look at your queries, you would look at this area first, right? Which is basically shows
the queries
which are running in PMM, right? And by default, we are sorting queries by load. What is load really? Load is basically how many active queries are concurrently active at the same time. Some people also refer to that as an average active session, right? Or you can think about that as a similar to as load average, just for the database environment. By default, we are showing you all the queries which exist in your environment, as well as where the load. So if we
side here,
we can see what majority of the load, or about 70%, comes from MySQL 4. That is either the slowest instance or it gets the most queries, but that is where the load comes the most. Now, you do not only have a feature to see the top queries, you can also look at the how the load behaves, right, and how it changes over time for different nodes, or you can look at the user, right? These are users which are creating load in database. So in our case, you can see majority of the load comes from App1, or even check out the client hosts, right? So like in your case, for example, it's maybe only one of the web servers, right, or app servers is generating the most load on the database environment, right, for whatever reason. you can see it here, even if that's the same client spreads its loads among the different databases. Now, let's look at the back at the queries. And if you want to check out what's going on with MySQL 4, we can click on to see what kind of queries specifically cause the load on this node, and we will be able to zero out on this specific query. Now, when we look at the query in particular, you can see a lot of information about the execution. How many queries we're having, right? Which is just 60 queries a second. How much load it generates. We can see how many rows it sends, as well as how many rows it examines. Wow! In this case, we're seeing what this query examines about 1.25 millions of rows per second, which is a lot, right? That is not a good thing. And what I think is even more important here is this section I highlighted. It scans about 20,000 rows for every row it sends, right? That means this query is very, very inefficient, right? So if you're wondering why this query is slow, well, you are already found it. Now, the next thing, if you to do, you may want to check out at the examples of the queries. And if you look at this query, you will see, well, this query doesn't seem bad, right? It actually is fetching a bit of data by the index. At the same time, if you run explain for this query, you will see what for some reason this query does a full table scan, right? Which is why it is slow. Why would it do a full table scan? Well, you can now proceed to see the tables which this query touches, and you can see in this case what this query works with is table called item 1. We just happen to have no keys. Well, the problem as such seems to be what somebody accidentally dropped the index on this node, or maybe it was forgotten to be created to begin with, right? That shows you a good example how you can look at the query. Okay, let's go back and see what we can, some more of the things what we offer. One thing I would pay attention is this. While for every query we are showing the query time, which is the average number, in many cases it is very helpful to understand also the variation, right? Because in many cases you will find not every the query execution will be the same. So in this case, we can see what the average per query is 13 milliseconds, right? And you will see what the maximum is almost 1 second, and the 99th percentile is 33 milliseconds. So in this case, you can see, well, this query have a reasonable average, but it actually has a pretty bad outliers if you look at the max. PMM is very flexible in terms of data you can change, right? Like, for example, here, instead of query time, I may look at rows examined, right? To add that column, right? And then I can order by that, and we will see the similar number. What we have about 1.2 millions of rows a second crunched by this query here. Now, while I showed here what is going on in terms of the queries, you can also click on this graph right here, and then I would get an instant summary. This is the feature which shows us all their details. I think it's taking a while to load, so let me just show you it here. What is on the node from its load standpoint, right? You can see both their properties of a system, like this is, simply, one virtual CPU with about megabytes of memory. MySQL summary output, right?
Also get a lot of
their operational details about the node, right? Like, for example, you would see their CPU usage, which is you are very familiar with that, most likely. The other graph which I like a lot is something which shows normalized CPU load. You can think about that as a portion of a CPU from the load average, average section. And in this case, where we can see what their normalized CPU load sometimes spikes as much as 7 or even more than 10, that is a clear giveaway what this system is quite overloaded from a CPU standpoint. We also look at have a memory activity, both as a physical memory as well as a virtual memory. When it comes to their database system, I look at the virtual memory very closely, because if a system runs out of a virtual memory, then guess what happens? The database will crash, will start doing crash recovery, which can take a long time, right? Because of that, I prefer to give enough virtual memory, so even if a system will be doing some swapping, it is not as bad, right, as if it's crashing. Especially for modern SSD-based system, a little bit of swapping is not a big problem. Now we can see the swap activity here as well, right? And you can see on this system, I would call it something like as a borderline, right? You can see every second there is, a few hundred kilobytes of swap in and out going, right? But that's kind of pretty persistent. That is not very good, because probably just a little bit more of a memory allocations can put that swap in to much higher numbers, but that is probably not horrible in terms of causing too much performance overhead as of yet, right? If you just have a few swap pages every so on, that is not a problem, right? You don't want to avoid that at all. Now, another thing what you want to often check from their disk standpoint is disk I/O latency. Unlike CPU, the disk is interesting, right? With CPU or memory, we have a very clear understanding what is the capacity of resource is, right? Like if I have 4 CPU cores, that means I can run 4 processes at once. And if I have more processes, well, they'll have to wait. If I have only 1 gigabyte of memory, well, that's how much memory I have. And if I allocate more, I will have to go to swap, right? Or I will run out of memory. When it comes to the disk I/O, especially in terms of storage, you do not really know how many I/O requests it can really execute at the same time, especially if you are speaking about network attached storage or SSD, it kind of gets quite complicated to understand that. Because of that, how I like to think about the disk is looking at its normal disk I/O latency, right, and compare that to the average latency. That is exactly what this graph here shows. We can look at the read latency and write latency for this device and compare them to the long-term average. And in this case, you can see actually something quite interesting, right? What we had this pretty significant spike on the I/O latency, even though the throughput didn't change for that about the hours. That means maybe because of noisy neighbors or something else, that storage backend was overloaded and was not performing as well as it started before or started to perform now. And because of that, we can see even if the I/O throughput stayed the same, disk I/O load has included here, right? Because if you have their latency for requests increases, then you need to run more of that requests concurrently to serve the same throughput, right? And that typically will then originate in the impact to the query performance. Now, in retransmits, right? You have maybe kind of several percent, right, what retransmit, and that can severely impact your database performance as it's seen by the application. The retransmits in particular are very ugly because you may find the application which sees a database, and the database is slow. Database may see it as, oh my gosh, I'm not getting any queries from application, I am idle, right? While actually
It's happened because of network quality, right? Which is in many cases
not understood appropriately. Then PMM also provides a lot of information about the MySQL, of course, right? About your connections, all the jazz you would expect, select queries, table logs, how much network traffic MySQL uses, internal memory, what kind of common complex start, and so on and so forth. But let me show something which but a lot of that stuff is actually pretty typical. You'll find them in many monitoring tools. Now let's see something which I think we have which are relatively unique. One here is a process state. What this really shows is essentially process list which is being sampled and aggregated, and what statuses we have seen in a show process list, which is actually quite cool, right? Because if something happens, have table log, right, or row level log, you may see piling up in the locate stage, right, or in updating stage, and so on, right? So looking at this, how the process statuses change, often can provide a lot of insights to troubleshoot problems. Where I think we do a lot of interesting stuff in PMM is in particular in the DB information. InnoDB is the most commonly used storage engine in MySQL, which performs a lot of low-level operations. So it is also responsible for a lot of actual potential performance problems. And you can see here, we can see all kind of stuff ranging from activity, what is going on. In this case, for example, we can see number of rows read and number of rows modified with information about what kind of operations are going on, right? Which can be very helpful if you see some meaningful spikes here. We can see different kinds of transactions going on and so forth, right? You would see their storage summary as well, where you can see overall for your InnoDB tables how much is taken by data, how much of that is how much of that is data index and so on and so on and so forth. The disk.io, that is another very valuable information you would find for InnoDB. And again, here we can see both data number of IOs, data bandwidth. Something I would in particularly look at, which I think is very helpful, is pending InnoDB IOs and pending fsyncs. If something is going on with your disks, right, pending IOs, then that is going to be very, very helpful. Okay. So let's move on to something else. Another, this is the feature which doesn't come with the PMM itself. But I think what is very cool about PMM is that it's built on a lot of open technologies, such as Prometheus ecosystem and Grafana, and that means that you can do a lot of extensions of PMM to meet maybe some additional needs you have. So what I was curious myself is to see what we can do in terms of looking at the processes which are running on the host. So I used the process exporter to get that data in the system, and then implemented the Grafana dashboard and loaded that in. And I will give you the link to the blog post if you want to see some more details about what is going on. Now, why would you want the process information? Well, because in many cases you may have something else than MySQL running on the system, and while you can speculate all resource usage comes from MySQL because that is what maybe that host is designed for, well, you don't really know. Sometimes something happens, ranging from somebody accidentally running the large script, or it could be even security incident which gets some process left running on your system, which takes resources, and you will be able to see all of that, right? So in this case, if you look at the CPU usage, we can see overall system CPU usage, as well as their top process used by CPU cores, which is in this case, we can see their MySQL used majority of resources, and then the second one is PMM agent, which takes what is about a tenth of a single CPU core, right? We can also see from the the memory usage, which I found very interesting here. We can see both resident memory usage, which shows us what is actually used in memory, as well as the used memory. What is used memory? Well, the used memory in this case is the memory which is used in the RAM as well as in a swap file. Right? This is, in my opinion, one of the most important indicators to show, okay, what kind of processes really do need memory in your system and how much. You may ask, well, what is about the virtual memory, right? Well, the problem with the virtual memory of those days is what many processes, they tend to allocate much more virtual memory than they actually use for all kinds of reasons. The MySQL is a good example here, right? We can see it allocates 1.3 gigabytes of virtual memory, while it only actually uses less than half a gigabyte. And finally, we can also see with our swap IO, okay, what exactly is going in the swap file. And we can see in this case is what the majority of the swap space is allocated either by MySQL process or by this process VM agent, which is a part of PMM. You can also look at the disk IO usage as part of a process, right, and some others. Let me now show you another pretty cool dashboard, which you will find, which now looks at more details for MySQL memory. Some of you may know what the MySQL has their tool called Performance Schema, and that captures a lot of operational information about MySQL, including in more details where different memory is spent. And why is that important? Well, MySQL uses more memory than you expected. You may want to be able to look into that and understand, okay, what exactly is what is that memory? What is that memory used for? Right. So in this case, we can see what MySQL total uses. So much memory per performance schema, and you can see that is kind of similar to used memory, right? We saw on the other page. It was 500 something megabytes. In this case, kind of it's slightly less than that because some of the areas are used by the code, right? And you can see a whole bunch of different type of allocations which MySQL uses, right? Then you can we can see, for example, from a client standpoint, which clients are using memory, and you can see what that memory seems to be growing in MySQL, which is allocated as belong to the user from particular host. I'm not quite sure why, but that's not super significant growth, right? Or over time, if that becomes super massive, then that is something you may want to look at. And we can see it some more advanced details. For example, to see what memory is used for InnoDB areas, right? And you can see here things like InnoDB buffer pool and various areas. The SQL that corresponds to memory usage, which corresponds to different functionality uses by MySQL SQL engine, and so on and so forth. And finally, let me show another dashboard, which I think quite interesting. Some of you may have heard about this method of performance optimization, which is called RED. RED stands for rate, errors, and duration, right? And it says that if we are looking at those three areas, we can often get the idea about how our systems are performing. In this case, we can see, for example, what the query rate has been pretty stable. Error rate, right, also in the system is pretty stable for 1 hour. While if you look at performance, we had a bit of spike in our 99th percentile latency, while average latency stayed the same. Again, that's maybe not very significant. We're just looking at the hour, but you can look at that. Then we can make a breakdown of this by the node, and we can see in this case what their MySQL 4 and MySQL 3 have a higher error rate. And you may remember what the MySQL 4 also had a poor performance. And then we can also see the latency as grouped by the node. Well, guess what? In this case, you can see what their average latency is a lot higher on MySQL 4 compared to their to the other nodes. And then we can, with that, potentially look at what is going on the MySQL 4 specifically, and hope we can analyze the data. I also computed a couple of other metrics in this case, which is not part of the original red method, but I found that is quite helpful. Like one is number of rows examined per row sent. I think that is a very good measure, right? As we discussed, what the queries are going to be much more efficient if that number is low. And we can see what the MySQL 4 is a huge outlier here, right? Another way to think about the query efficiency is also to see, okay, if you think about the row which is generated in the database, how much time does it take that, right? Again, in this case, a MySQL 4 is quite a bit outlier compared to our stuff which produce the data pretty quickly. And finally, we can also look from a load standpoint, both the queries per host, right? What is an inflow is, and we can see in this case the MySQL 2 and MySQL 1, right? They get more of a queries. And we can also look at the query load per host, right? That tells us, okay, in terms of query load or average active queries, where do those come from? And in this regard, we can see again our MySQL 4 being a nasty outlier, which has a lot more active queries on average compared to the other hosts. So anyway, with that, I wanted to say what you can see. You get a lot of this information, right? You can get from Percona monitoring and management. Some of that is pretty easy, and some of that is more advanced. I also showed you some of additional dashboard which are not part of a PMM, but which are sort of experimental extensions which we have created and evaluating before including the core product. And here are the links to the blog post about how to add and use those if you want to learn more details. With that, that's all I had. And let me leave a few minutes. If you folks have questions, please type them into the chat. Okay. Okay. Yeah, so we have a couple of questions. First, about the query examples. Well, generally PMM would should capture those automatically, especially if you have using a slow query log. Now, as example, in performance schema, there may be some cases when that is not available, right? So I would you may use our forum to maybe post more direct questions, and we can help you out there. So the query analytics and IO metrics, right? So the IO metrics I showed, they come from slow query log, right? We obviously only can get metrics available which are exposed, and the performance schema does not provide them. I think in MariaDB you may need to enable the additional login parameters if you want to get them. Okay, and I see a question from Robert Hoffman about the node processes. Does it require a newer version of PMM2, or can I just import? Well, this is the external dashboard, right? So you'll need to install it separately, and it will work with newer versions of PMM2, right? I think something which was released over the last 3 months or so, because it uses external explorer functionality. Okay, yes, so there is an ask to copy paste the blogs post. Well, yes, I can do that. That is a good idea. Thank you, Jennifer. Okay, hello. Okay, interesting. Oh my gosh, this is like too long. Yeah, I think I should be so easy, but I think it's very tricky. I think the okay. I think the rest of them they copied not very nicely, but you anyway, you should be able to get them from the slides as well. Their chat window in this system is not particularly robust. So the question was about the peak time in PM in a MySQL server over the last 3 months. So in PMM, you have the settings page where you would configure how long to retain the data. I think by default, we keep it for 30 days, right? Or you keep it because that runs in your environment. But you can change it to 3 months or more. And if you need to analyze that over 3 months, what was going on, then you will need to extend the data storage. Sandy has asked about the variables which are impacting performance. Well, I will name you just a couple. One is InnoDB log, InnoDB buffer pool size, right? That is typically most important. Then also you want to have InnoDB flash method equals to ODirect. That is typically best for most environments. Also you may want to think about InnoDB log file size, which is important, especially for serious write workloads. Okay, let's see. I mean, yeah, so Mark is asking about the integrating sysbench and PMM. So currently we don't have a plans to do that, but we would want to have an extension interface so that is possible, right? If somebody wants to do that, we did not really hadn't plans to incorporate benchmarking in PMM at this point. How many maximum instances can we add to PMM? So I would say the 1,000 is a number what I have tested with, right? But typically a lot of that will depend on the resources what you allocate to a PMM server. Does PMM work with multiple MySQL? In MySQL multi, yes. I mean, you can run multiple MySQL instances on a single node in any way you like. So Sandy Kumar is also asking about the alerts for group replication. So we have now alerting functionality in PMM, and you can create a custom alerts for failure in group replication if you choose to. Okay, let's see. Well, so Michael is asking about ability to see table DDL and query analytics even if an alias is used in the query. Well, I don't remember in this case whether it works or doesn't. But if it doesn't work, then I would make sure to report that that as a bug, right? And we'll see if that's possible to fix it. So for Sani is asking, can you set up custom alerts for MySQL and PMM? And the answer is yes. There is now what we call the integrated alerting feature in PMM, which is in the feature preview, which you can use to do it. And I think we have a session in Percona Live about this topic as well. Yeah, let me also copy you something. Hello. I'm not sure what. Okay, so what are the other parameters other than slow query that can impact application speed? Well, if it's not related to a database, then you may want to use the tool often available with your development framework to profile the applications to understand the time is actually spent. It may be all kind of things if it's not the database. Okay. Okay, folks. Well, looks like that's mostly it.